All right, this is part number 2 on significant figures. Now we're continuing with the notes that we just got done with in regards to quantitative measurements, qualitative accuracy, and precision. Now we're looking at the significant figure rules. All right, so we just got done talking about the targets. So now when we look at significant figures, what we're going to do is we're going to be looking at measurements or numbers. Right, and significant. At this point, what's going to happen is some of your thoughts that you've always had in regards to math are going to kind of get distorted or messed up. I'm not teaching you wrong, nor have the math teachers taught you wrong. It's just looking at measurements in a scientific sense, right? So I'm going to get rid of this, and we got to look at the first rule to figure out if something is, or measurements are significant. If I have a measurement like 739 grams. So I have 739 grams. If we look at this measurement, right, you went to the back of the room, you measured the mass of something, it came up to be this. I want to know how many of those measurements are significant. How many of those did you measure is what significant means, right? Don't get confused thinking that significant means important, okay? Because that's going to be the piece that's going to make it mess you up. It's which ones did you actually measure? Well, what you would find is you measured all three of those. You measured 700, you measured 30, and you measured 9. You measured all three. So all three of these digits are significant. And according to rule letter A, they are all significant because they are all three non-zeros. Right? So this measurement would have 3 significant figures. Each figure is significant. Each figure was measured. Right? Rule letter A, I think, is the easiest one. If you have a digit between 1 and 9, they are significant, right? Now the only digits that's left, 0. And 0 brings about all of the questions that occur. And those are the next set of rules. Rule letter B says zeros between non-zeros are significant. So let's go with this. We're going to go 203 grams. So when we look at this measurement, you went back and measured something and measured 203 grams. How many of these figures are significant? How many of them did you measure? Well, we know you measured the 2 and the 3 according to the rule, letter A, because those are non-zeros. So we have 2 significant figures to start with. The question is that 0? Is that 0 significant? Yes. According to rule B, zeros that are between non-zeros are significant. So this one is significant. So this measurement actually has 3 significant figures again. Now, one way to look at this, another way, and I don't like to do this because it can get confusing, but if you took out that 0, would you still have 203? No, you'd have 23 grams, and that's definitely way different than 203. So that 0 needs to be there. We did actually measure it, so it is significant. So that was rule letter B. Now let's go to rule letter C. Let me get rid of these, and I'm going to try a different one. This one, some of this is actually really straightforward. If we have 343 grams, okay, if I put zeros out in front of this, so I made it 343 grams. Are those zeros significant? Do they need to be there? Well, if you were in Mr. Madziar's class, he'd probably say, no, you don't have to put those zeros. Don't bother. I don't. It's still 343. And you know what? I would agree with him. That's right. These 2 zeros are not significant because they are out in front of the number, right? And that was what letter C says. Zeros in front of non-zeros are not significant. So this measurement right here has 3 significant figures. This guy, this one, and that one. The zeros are not significant. Oh, but now let's try some harder ones. What if I had this? 0.0023 grams. Well, we know the 3 and the 2 are significant. So that gives me 2 significant figures. What about those zeros? This is when it starts to get confusing because you're like, yeah, well, according to Mr. Madziar, yep, we've got to have these 2 zeros here in order to bump that 2 over where it belongs. And you know what? I would agree with him. But those zeros are not significant because they are in front of the number. Right? As long as they're in front of the number, they are not significant. All they are is placeholders to push the 2 over to where it belongs. Right? The way in which you can know as to whether or not they are not significant, then what you have to do is you have to rewrite this number as scientific notation. oh my gosh, scientific notation. Scientific notation means I got to have one non-zero in front of the decimal. Right now I got a 0 in front of the decimal. That's not right. I got to put the 2 in front of the decimal. So I need to make this 2 point. So I'm going to put the point right here and make it 2.3. But 2.3 is not the same as 0.0023. So what I got to say is I got to say times 10. And then I got to figure, well, how far did I move that decimal? Well, the decimal went from here over to there. So it went 1, 2, 3 jumps. So it went 3 jumps. So it's 2.3 times 10 to the third. And then we got to know, is that 3 a positive or negative? Well, the way in which I try and teach this is go back to the original number that was there. Is that number bigger or smaller than 1? Well, that number is way smaller than 1. Because it's smaller than 1, this is a negative 3, right? So now that I've rewritten it, this number over here is exactly the same as that number. It's just a different way of writing it is all. And what happens is the 2 and the 3, those are my significant figures. Right? Both of those are significant. This, the times 10 to the negative 3, just tells me really where the decimal is supposed to be, because it's not supposed to be between the 2 and the 3. It's actually supposed to be way over here, and that's what the times 10 to the negative third tells me. So in order to help you with the idea of figuring out rule letter C, is if you rewrite them in scientific notation, then that'll help point out as to what is significant. Right? So these zeros that are out in front are not significant. All they are is placeholders, is all that they are. Okay? All right, so that was rule letter C. Now we go to rule letter D. Let me get rid of these again. So rule letter D, zeros at the end of a number to the right of the decimal are significant. So if we say that 23.00, right, are those zeros significant? No, this starts to get really confusing now, right? Because you look at this and go, if you're in math class and you looked at that and you wrote down 23, or you wrote down 23.00, yes, a math teacher would tell you, yep, both of those numbers are the same. But in science, when we're doing measurements, they're not the same. 23 and 23.00 represent different measurements. Right? What it does, it tells me where I rounded this number off at. All right, where did I round it off at? I didn't round off the 3. Because if I rounded off the 3, I would have only written 23. Instead, what I did is I rounded off at this spot. And the next number over was like a 2. Because it was a 2, then I kept this thing as a 0. Okay? So I know that this measurement was, man, it was right on 23.00. Okay? So this one actually has, this guy is significant, the 2 is significant, the 3 is significant, and the 2 zeros are significant because they are at the end of the number and to the right of the decimal. Right? They do need to be to the right of the decimal in order to know whether or not they are significant or not. Okay. Again, what you can do on this is rewrite it in scientific notation. If I rewrote this one in scientific notation, then I would rewrite it as 2.3. I got to get this decimal, so I have one non-zero in front of the decimal. Then I go 0, 0. Oh, hold on. Let me get my lights back on. Sorry about that. My lights are on a timer, and there has to be motion in order to keep them on. And I'm not in the spot where the motion is. But so I did 2.300, and then I go times 10. And how many did I move it over? I moved it over 1. Was the number that I started with, was it bigger or smaller than 1? It was bigger, so it stays a positive 1 this time instead of a negative 1. All right, so those zeros are significant. Now, what ends up happening on this is really what it's trying to tell me is let me do a different number here. Let's go 7.000. Are those significant? Yes, all three of those zeros are significant, and the 7. So this guy has 4 significant numbers. What it really tells me is where I rounded this thing off. If I rounded off at the 7, that means I would have looked at the 0. So this would be somewhere between 7.4 and 6.5. Okay? So this measurement is somewhere in between those. Well, that's actually a range of 0.9. That's a really, really big range. It's a big space The accurate measurement is somewhere in between there. I'm not very precise. In other words, I'm not going to be able to get the same answer over and over and over because I have such a big range here. Right? Nor am I going to be able to be very accurate because I'm not going to be able to get that right answer. I'm way far away from it. Right? So rounding it off at that point doesn't make me very accurate. And also, I'm not going to be able to be very precise because I have so many different measurements that I could end up with. So that's what if we rounded it off there. Now, if I go to the next spot, try a different color. If I rounded it off to this one and went to there, right, so I'd have to look at the next 0. What this actually does is this round takes it down to that. All right, so now we're looking at somewhere between 6.95 and 7.04. What's this range? This range is, instead of 0.9, it's 0.09. So now I'm looking at a smaller amount of space. Right? So I'm going to be closer to the right answer. I can be more accurate on this because I got a smaller range of measurements in between there. All right? So this gets me the ability to be more accurate because there's a smaller range. Now if I go even further over, let's go to the next spot, and we'll use green for this one. If I rounded it off to this one, I have to look at that. This now makes it 6.995 or 7.004. So what is this range? This range is now 0.009, right? So I'm looking at even a smaller amount of space. I can be even more accurate. I'm really accurate. That right answer is somewhere in here, right? That's a whole lot smaller range than what I had with the red measurements. The red measurements, that was a big range. The right answer was somewhere in there, but it was really far away, right? And if I go even to the next one, the very last one, and we'll go to black to this, I rounded off to this spot, looked at the next one, that's somewhere in here, right? And that's actually going to be a range of 0.0009. That is really, really, really small. I'm going to be really, really close to the right answer. I can be very, very accurate, right? And that's what this whole idea is with significant figures, is trying to figure out where did the measurement get rounded off at, and how close am I to the right answer, right? The very last rule before in the next video, we'll talk about rounding off answers. The last one I want to talk about in this is letter E, and that is if you write the numbers as scientific notation, that will help you identify those significant figures. So if you have a measurement like 300, we really can't tell if those zeros are significant. We got to write it in scientific notation. So scientific notation means I take this decimal, bump it over so that I have one non-zero in front of the decimal, so I'd have 3.00, and then I go times 10. How many did I bump it over? 1, 2, so it's a 2, right? And then was that bigger or smaller than 1? It's bigger than 1, so it stays at a positive 2. Now that I look at this, this is significant. The 3 is, because it's a non-zero. That was rule letter A. And these two zeros are significant because they're at the end of the number and to the right of the decimal. That was rule letter D, so all 3 of those are significant. The way it's written over here, I can't tell until I write it as scientific notation, so that's rule letter E. All right, with that, you're going to go on and watch video number 3 to show you how to round these guys off.